doing a demo of a subtitling system. Yeah, thank you, Hervé, for the next slide. Yeah, so it's a pretty simple system. We're going to connect to our streaming Diarization API, of course. And we're going to work together with the OpenAI Realtime API for transcription. And then the idea is that we're going to combine this to have one speaker attributed subtitle and then stream that back to a front end in the browser to actually display speaker labels on top of a video. And we'll share the code, of course, in a public repository in GitHub. You can find some of our previous tutorials as well. And you can get a deeper dive into the code. Yeah, go ahead to the next slide, please. Thank you. Yeah, so this is a basic architecture overview. The tech stack is, we'll use TypeScript, and we have a Bun and Hono-based server. This will basically receive the audio chunks from the front end, from the client, and then stream that to our API for diarization, and also to the real-time API of OpenAI to get the transcription, and then send that back to the client side. And it's really just an abstraction, so that the browser doesn't care what API you're using. It just receives those subtitles with speaker labels. And yeah, we'll use the SDK from OpenAI, and we'll use our own API, of course, as well. So you need an API key for both the providers. You need to have Bun installed on your machine to test this. You need a browser. And we'll use a pre-recorded video file right now, just to have some control over this demo, but you could easily swap this out for an actual stream of audio from a microphone or some other type of stream. So yeah, so we'll just use this video file, but you can swap that out. So I'll now share my screen to show you what it looks like, and I'll show you a demo of it. So let me do this right now. We'll start my local server. So yeah, this is the video player inside of a browser. And as soon as I hit, you can see actually in the bottom right, there's a status label. So you can see the status of our API, and we send this to the client side as well. And as soon as I hit play on this video, we'll start initializing both of the APIs. And then once they're ready, we're going to send chunks of audio. And then you'll see, so there's maybe like a second or delay before you actually see the subtitles on the screen, but they will show up, and then you can see like the actual live subtitles of this video. So I'll just show you this short clip, and then we'll dive into the code a bit to see how it works.
Satiated on those robots, then it's a very different story. Yeah,
right. But now we're talking about the consumption world, whereas for the investment side of things, there could be just some greedy titan of industry who keeps wanting more and more robots. And that alone would be enough.
It would.
To increase the marginal value of robots and therefore decrease labor share?
Yes.
Yeah. Okay. But why are we not expecting greedy titans of industry to keep existing?
I mean, greedy titans of industry historically have like built library.
Okay, so that was the short demo. You could see the transcript chunks and the speaker labels being streamed to the client. So let's go a bit over the components of the code of this demo. So yeah, the first part is really just in the browser side, you load this video file, which again can be a microphone or anything, and we use relatively modern browser feature called a worklet to get that audio stream separately from the UI thread, and this is just to make sure it doesn't block the actual rendering of the things that you see on screen. And then, so we use that worklet to get the actual audio, and then we downsample it, and we create frames of 100 milliseconds. And this is just because our API expects this, our Diarization API expects this shape of the data. And then we send this to the server side of this application, which is the next step. So actually, these steps kind of go at the same time. When you hit play, we initialize the streams. So for us, you can see our API with a simple HTTP call to get the WebSocket URL. And for OpenAI, we used their SDK. We wait for both of them to be ready. And we send that back to the browser side, basically as a signal to say like, hey, you can start sending the actual audio chunks. And then back on the server side, where we receive the chunks, we can just send them almost directly to our streaming diarization API. And OpenAI wants a slightly different format and a slightly different sample rate. So we have to resample this. And you'll find this across other STT providers, like every STT provider, transcription provider has a slightly different requirement for the sample rate and chunk size. So yeah, you always likely right now have to do some resampling, but typically that's okay. You could see in the demo, like it was still pretty fast with returning the results. So yeah, that's the next step. You receive the speaker turns. The data is you get the speaker label, the timestamp, and whether it's a start or an end of the turn. And this is also the part where it gets a bit complicated because, you know, like we've mentioned before, we can actually detect the overlapping speech, but a transcript is usually from one of the speakers. So we just assign, you know, we keep track of the current active speakers if there are multiple, and we try to assign it to the right transcript segment. Another thing to note here as well is that at the end of a speaker turn, we commit the current buffer of audio samples to the OpenAI transcription API. And this is because, and you'll find this in the other STT providers as well, they send a partial transcript, which is sort of the initial one, and then a final transcript, which can be slightly more accurate. So depending on your use case, you might want to only use the partial if you're really going to get, if you really want the lowest latency. If you want slightly more accurate, you can use the, just wait for the final transcript chunk. And that, yeah, kind of depends what exactly you want to do. Yeah, and then for the next step, one of the last steps, thank you. So yeah, we assign the labels that we receive from our diarization API to the transcript segments. And then we wait till the end. And if there's some overlapping speech, we decide whether it's like the whole segment or just a small interjection. And if it's like it's just a small part, then we just leave the main segment as like the initial speaker, and we don't swap that out. And then, yeah, we simply stream that back to the browser side, to the client side with the events, the actual speaker label and the text. And then, yeah, the browser renders this. We added some colors and overlaying this on top of the video to show this. And we've got a lot of feedback during the beta on reconciling these subtitles or reconciling segments and speaker labels. So I think we'll do some more investigation about like what's the optimal way to do this, especially across multiple STT providers. We're still figuring out what's the best way. There are so many possibilities, and it kind of depends on your exact use case. So yeah, we'll definitely get back to that. So yeah, this demo is just a start. You can of course swap it out with another STT provider if you like. You can swap it out and use your microphone as input or some other type of audio stream. And of course, obvious thing to think about, you can throw these the transcript segments to an LLM to get translations. You get live translated subtitles, or go for more challenging use case as well, where you not only translate, but you also do voice cloning and text-to-speech to get live dubbing. And yes, we talked about before, you can have the AI note taker or like a AI meeting assistant. For example, you could periodically send the transcript with the speaker labels to some LLM to get some notes, or some other maybe action items or something. And yeah, this demo is really the start of this. You can build things on top of it. That's the idea. You can swap things out. And of course, this is just a browser and server-based application, but you could build something. You know, our API is just WebSockets and HTTP API. So yeah, you could build a desktop application as well, maybe in Rust or something. And again, I invite you definitely to take a look at our code of this demo on the tutorials repository on our GitHub to have a deeper dive into this as well. And I think that's it for this demo.